All right, so our independent variable is what I change one, and I only change one thing at a time. What's the dependent variable, Audrey?
The one variable that gets measured.
Yep, it is the data that is measured.
You're right.
If you wrote something else, that's fine. I'm just using those same tricks. Remember the D in data, thank you very much. The I in I change. Is there anything else that you think we should write for those variables? Okay. What about the control variable? These are also known as our constants. Sam Hughes.
The variable that stays the same.
Yes, so why do we want to make sure that we have things that stay the same? Why would we want to make sure we have things that stay the same?
So we don't have too many.
Yeah, because remember, we can only change one thing at a time. So these are all the things that stay the same. To ensure we only have one IV. I only want to change one thing. If I change more than one thing, I will never know. I will never be able to interpret my results. I won't know which thing caused the change, right? One other thing I want to write for the IV and the DV. The independent variable is the cause. The dependent variable is the effect that we measure. So remember, experiments always help to determine a cause and effect relationship. So what I change is the cause, and then what's being measured is the effect as a result of what I caused. Does that make sense? Okay. Control group. There, our group here. Go ahead, Amiri.
The group that has nothing happening to it that makes mistakes.
Yeah, this is our OG. Remember our OG group, our original gangster group. This is the one that goes without. So this does not receive the IV. It's the group that goes without, and it's used as a comparison. It's used as a comparison. It's our OG group, the original group. Now, the reason I specified that it doesn't receive the IV is because, like, what if we did an experiment about whether eating breakfast affects your how you do in school? Well, if you normally eat breakfast, you might think that that's the control group. But it's the group that doesn't eat breakfast that would be the control group. It's always the group that goes without. It's always the group that goes without, the one that doesn't get the change, so that I can measure the effect of that change. Right. My experimental group is the one that I'm testing. Think about what's not normal. Is it normal to put ice on a frog? No, that's why our experimental group was the one that got the ice, right? Your experimental group is the group that does receive the IV, or the condition / group that does receive the change. So we've got that group that does not and the group that does. I'm experimenting with it. If it receives the IV, it means that it's getting experimented on, right? What about our hypothesis? Somebody from home help me with this one. What did you write as the definition for hypothesis? Ohm?
I wrote an educated guess based on observations and inferences.
Perfect. Well, the hypothesis is like the inference. It's like what we think will happen, right? But it is based on evidence, whether it's observation or personal experience or prior knowledge. So we're going to say an educated guess based on evidence. And I'm going to specify what that evidence is. It's either observation or prior knowledge. If you don't have what I have, you should be fixing it. Or if there's something that I wrote that you feel like would help you, I want you to add it too. There's a very specific reason that I use the words that I do. So that when you guys, yes, a very specific reason. Fiona will tell you she was in tutoring with me yesterday. And is there not? There is. So there is a method to the reason why I'm repeating the same words over and over again. And I focus on certain words because you need to know them. Just saying. All right, what about observation? When we gather information using our, call it out, eyes, ears, mouth, nose, head, shoulders, knees, toes, all of the above. This is when we gather information using our 5 senses. Eyes, ears, mouth, nose. That's a really big finger. Hands. What about an inference? What about an inference? Make sure there's a specific thing I'm looking for here. Amelia, you think you got it? A conclusion made from observations. So did anybody put anything different? A guess? Okay. I want you to make sure it's based on something though, right? Like, remember we were talking about how I said if I heard something on the roof, but my prior knowledge told me that it wasn't December, so it definitely couldn't be Santa. Okay, that's fine. That's fine. So a conclusion. Did you have something different, Michael?
No, I did the same thing you did.
Okay. A conclusion based on observations. I used to have this first grade teacher named Miss Hamlet, and she would every week have a coffee container that had like a hole drilled in it and like a sock or something like that your hand went into. So you couldn't see the top, but you could feel inside of it. And she would give a prize to anybody who could guess what was in the coffee container that week. So I always used to guess, and it was just fun. She was trying to teach us about using our senses and all that first grade stuff. So I remember feeling one time, and you could tell it was a coin, but it didn't have a rigid edge. And there's only one coin that's a small coin that doesn't have a rigid edge. Does anybody know what it is?
Dime.
No, smaller than that.
Dime.
Dimes have rigid edges. It's a penny. So you had to have known, like the nickel is bigger than a penny. So you had to have been able to compare it in your mind, right? Diamonds do have rigid edges.
What's that silver one that doesn't?
A nickel. But they're bigger than pennies. So it was kind of cool because you had to have really been paying attention to really small details to been able to guess it. I won that week. Just saying. All right, so a lot of people are like, what does it mean by all experiments have? What do I always say? We did this last week when we were looking at the do-nows.
All experiments have an IV, a DV, and a CV.
Yes, an IV and a DV, which makes them testable, right? Remember we practiced our testable question format. How does our IV affect our DV? And then that group did something that was so miraculous, and I loved it so much. They were like, but you also need a control variables or constants, because otherwise you'll have more than one independent variable and that can't happen. So I'm going to go back and just remind myself that that's what a CV is a constant variable. But they were absolutely right. If I definitely need IVs and a DV to make sure it's testable, but if I don't have CVs, if I don't have a control of a constant variable, then I'm going to be measuring more than or changing more than one thing at a time, and that can't happen in a controlled experiment. All right, this is a very important question because there's about 4 or 5 questions on the test that ask about this. Why is it important? Somebody from home, Kavar, why is it important that we repeat experiments? I can't hear you. You're on mute.
So you get the same data as the first time?
All right, so we want to make sure that our results are correct. Sam?
Validate your data.
Validate. Good. I'm so glad that you said that. Anything else? What's another word that we used other than valid? It begins with a V. And remember I talked about the word verdad in Spanish and veritas. There's a word that has that part.
Verify.
Verify. Perfect. So I also want to remind you that another word for repeat is replicate. And if you didn't know that, the idea that a replica is to copy something, right? But it's important because we want to verify and validate our data. So to make sure we're correct. And I also want to make sure I share all parts. Do you remember the question about the professor and his technician and his assistant? We want to share all parts. And we want to be clear about our directions. Like I used to do this thing, and we didn't get to do it this year because of the pandemic, but I used to do this thing where I would have every group write the directions on how to make a peanut butter and jelly sandwich. And then you would trade directions with somebody, and you would follow those directions exactly. So if it didn't say you could use a knife to spread the peanut butter, you couldn't. If it didn't say that you had to use 2 pieces of bread, you only put it on 1 bread. So it was showing that, like, if you don't write directions clearly, someone else will interpret them wrong. I have like look how much peanut, for real, I have so much peanut butter left over. But we did this to show you guys that directions have to be clear. Otherwise, you have no idea how someone else is going to interpret them. Do you know what I mean? If we things ever go back to normal, maybe we'll do it to see if you guys can write really good directions. All right, let's flip it. I hope that you guys went back to some of your assignments to look at this. These are also on your study islands. There's a whole section on theories and laws. What is the difference, Sam Hughes?
Laws, well, theories haven't been like completely proved yet. Well, because laws, they describe what will happen every single time, and theories are like what science, they've been tested by many scientists, but they haven't been.
They can change. They can change. So remember we said theory, the word theory has a Y in it because they describe why things, or they explain why things happen. They are tested many many times. So many times. Otherwise, we don't know, like I said, we need to make sure that they are consistently true. But they can change. Theories can change. Laws, on the other hand, laws describe a pattern in nature. Remember we said the W stands for what? It like describes what happens. We talked about how we use drinking and driving as an example. The law itself uses math to tell me exactly what it means to drink and drive. 0.08. That's the line. But I could theorize or explain why I think you might do it, right? But a law is going to tell me what exactly it means. It's describing it. And like I said, they usually use math. They usually use math. The most important part of this, I'm not going to lie, is knowing that they can change and they're tested many, 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 many times. Laws don't change. Laws are like they're written in stone, like the 10 Commandments of science, if you will. Theories can change, though. We talked about this. It should say, how do we use I want to say why and how. Because we can answer both those questions. How do we, or why do we use models in science? Why? Think about the study island question that we talked about before. Why might we use models?
You use models of something that is like too big or too dangerous to work with in person.
Good. So some things are too big or too dangerous to work with. Sometimes we don't have the ability to actually have the real material. Like, I can't go to the planets, y'all. Can't, unfortunately. They may be out of reach. And you can do a model even with a drawing. You can drawing something out like we did in the Do Now this morning. That's a model. And we use them to clarify things, clarify and gain better understanding. We clarify and gain better understanding. Why do scientific conclusions that are based on reliable data sometimes change? Why might scientific conclusions change? What do we think? Amiri?
We could get more advanced technology to test out different ways.
So if we get new technology, what might we gain? More knowledge. Good. That's exactly what I'm looking for. Sometimes new information can lead to new ways of thinking. New information can lead to new ways of thinking. Think about all the stuff that we do now. Like you guys, think about how we've adapted to virtual learning, to mobile learning, right? That would have never been an option when I was in school. They didn't have the technology. But now that we know we have it, it's led to us designing an entirely new model for education, which is pretty cool. When sharing the steps and methods of scientific investigations, we should always Well, how should we share our steps to scientific investigations? Think about the peanut butter and jelly. Somebody at home. When I'm sharing directions for a scientific investigation, I want somebody other than Om or Kavar. Go ahead, Samyukta.
We should always have accurate data.
We should always have accurate data, but I also want to make sure that my steps are what, Trey? That they're in order and they're descriptive and specific. So we should always share. I like that you said descriptive and specific methods. We should always share descriptive and specific methods. So that others can follow it exactly. We share everything. They need to follow everything we do exactly, like a recipe. Oh, Samyukta, I didn't even see your chat until just now. What did you say for inference? I know that it was about a while ago.
I said a prediction backed up with evidence.
Oh, okay. I like that. A prediction that's backed up with evidence because it applies more directly to what a hypothesis is, which is like the same thing as an inference. At least in science, we're just taking an English word and turning it into a science word. All right. Being able to apply what you know about experimental design. You should know this because we practiced those questions earlier last week, right? So our testable question is, how does adding salt water affect how tall a plant grows? What's my independent variable, Alex? Yep. So I'm going to do salt water or no salt water. You could also say the amount of salt water. So you're going to give the same amount. So you're right, but I could say either giving salt water or not giving salt water. So I'll cross that out because you're absolutely right. I should give the same amount to the plants if they do get salt water. I like that you called me out in a very respectful way. What's my dependent variable, Fiona? Yep, plant height. What's my control group? My control group. Layla. Yep, so the plant with regular water. That keyword is regular or normal, right? Ariel, what is my experimental group? Perfect, plant with salt water. All right, so we're going back to those constants now. I want to give the same amount of water to both groups, whether it's salt water or regular water. And Trey already pointed that out. What else, Jasmine? The same type of plant. Cat? Perfect. I would say same amount of water and schedule, like the same watering schedule. Brianna, what's another thing that should remain constant?
The amount of sunlight.
The amount of sunlight. Perfect. We could go on forever with this. Oh my gosh, I love all these hands, Jayla.
Like, where is it?
The location. There's a couple other things I could think of. Amiri.
The type of plant.
So the same type of plant, but what else would have to be the same along those lines?
The type of soil.
Type of soil. Something else along those lines. What else do plants need? Alex.
Then to, I thought it was just like, but what I was going to say was, all the plant heights have to be the same.
Well, I can always start them from seeds, right? Or I can start them from the same point of growth. So that would be like the same type of plant. So whether it's the same, they're both seeds or they're both in the baby stage, I can measure where they started and then over time measure how much they grew and then conduct my analysis over time, right? Amelia, whether or not I use fertilizer,
The temperature.
the same environment or location, I'm gonna say same pot, same type of pots. And the reason I say that is because as a plant advocate, I know that some plants do not grow well in like plastic pots. Sometimes they don't do well if they're in galvanized pots. So different pots have different effects. Jasmine? So, okay, so I want to make sure that every time I'm using the same type of salt on that specific group. And then last one. And the same type of water, whether I'm using tap water or bottled water or purified water. Thank you. Do you see how many things you have to make sure are the same? All right, flip it. Now, some of you guys were confused by this, and I'm so sorry for that. This hypothesis was supposed to go on the last page. So we were supposed to write a hypothesis that goes with the prior experiment, but it got cut off. Remember, we always do if and then. So if I change this, then our prediction. So if I add salt water, then what do we think will happen to the height of the plant? Thumbs up if you think it'll go up, thumbs down if you think it'll go down. Okay, does anyone want to tell me why they think that based on their prior knowledge? Michael?
Salt normally like dissolves.
It does dissolve, but it also does something else.
Salt normally sucks up the water like it dehydrates.
It dehydrates. Salt is a dehydrator. So based on our prior knowledge, our hypothesis is going to say then the plant will not grow as tall.
Miss Burley,
Yes, babe.
I can't see the top.
Oh, I'm so sorry. Thank you. What do we do if our hypothesis is not supported by our data? What do we do? What do we do? Samantha. And then repeat our experiment. So we revise our hypothesis. And only after we've revised our hypothesis do we repeat it. So we first revise and then second repeat. When we watched the Brain Pop, or if you watch the Brain Pop, it talked about this and it said back to the drawing board, right? If your hypothesis is wrong, you kind of start over. And that's okay. It's all right to start over. The only way that this last part is going to be filled out is if we sing it, y'all.
Yes. Yeah.
I'm just saying. What's that? Okay.
Yeah.
Hold on.
No, just the
Ojos. Thank you.
in my mom's class, whenever they were doing the salt water and the gummy bear, I'm pretty sure that the bear was just completely preserved.
Yeah, because salt, actually, I'm glad you used the word preserved. Back in like the times of Christopher Columbus, Salt was super important because they go on these long trips, right? They go on these long trips, and in order to preserve all of the food, they had to add salt. Have you ever noticed that the sodium levels in canned goods is so much higher than sodium, like canned vegetables, is so much higher than natural sodium of vegetables? Because salt is a preservative. It helps to preserve things. And I was just talking to Mr. Johnson about how back in the day, Vikings, they couldn't get salt very well because where they lived, it was too cold. They couldn't harness it from the ocean. They didn't have it in their environment, I guess. So it was a big commodity. They were willing to trade for it, but they also didn't have a lot of stuff that they could keep preserved because they didn't have salt. All right, let's do this. Ready? Yes. All right, here we go. Are you ready? You ready to hear a song? Because we're about to sing a song. Okay. Welcome to my lab. We can ask a question, gather information. We can... What? Welcome to my lab. We can... Hey, that's right, guys. So we can ask a question. We can gather information. Form our hypothesis. Test our hypothesis. Draw conclusions. And report results. At this point, you have everything you need to be successful on the quiz, on the test. You have everything that you need.